All right. All right, guys. I hope you can see me. Um, we're gonna share this link with more people right now. Uh, I would appreciate if you can write in the chat anything. Let's see. Oops. Okay. So, yeah, I'll be waiting for someone to write in the chat. The stream starts at like in 6 minutes because I cannot say which exact time it is for you guys, but in my time it will be 10 p.m. And I'm just gonna share the link with more people right now while we're waiting for them to join. Any feedback about the quality of audio and video I would appreciate highly. And I'm just gonna go ahead and share the link. If you hear any background noise, I'm sorry. That's something that happens. There are other people right now. Some of them are maybe even playing games in my apartment. But hopefully we will not get interfered too much. The stream will last for 1 hour till 23 or 11 p.m. Let's see. All right, I'm just gonna go back now to the dashboard. Let's see. Okay, hello. We get our first comment here. I'm just gonna quickly recap what's up and why am I streaming even. I'm gonna do that when the stream starts in 4 minutes. For now, let me quickly see what we have here in the settings. I'm gonna share with you guys some stuff, some tips and tricks about blueprints, and today's topic will be about asynchronous execution of stuff in the blueprints. And I'm gonna, by the way, I'm gonna reiterate this again in a couple of minutes whenever we start. I'm not sure about the quality, but hopefully it's fine. And we're just gonna wait for the start. I have to repurpose my toolbar here because I use much more wide monitor. Okay. And that's the thing. Alright. I have quite a lot of topics actually here today. If you look here, I have like reactive programming, timers, performance metrics, blueprint debugging. Yes, thank you for the feedback. Quality is one of the key things here, because if you cannot see what is written here, then it will be impossible to actually share the knowledge. C++, I don't know, I don't think we will get into, but hopefully there will be time in next stream or something like that. Let's see, we have 3 minutes to start. While we are at it, let me quickly tell you about why this stream is even live. For last 8 months, I believe, I haven't published a single video, and that sucks. That's connected to the fact that I'm deep into basically 2 full-time jobs right now, so it's kind of like it's getting really hard to actually maintain a channel at the same time, so I'm just not maintaining the channel, which is not the way to do it. But what I am doing right now is working on a game title, and actually I'm working with other people, and it happened It happened to be such that I am the most experienced Blueprint developer out of our guys, at least for the time being. And so because of that, I decided to do like weekly streams about the Blueprints programming, and later on maybe even CPP programming in Unreal, with our like staff, essentially with other people who work with me on the game. And I streamed for 1 hour like 2 weeks ago. That stream was unlisted, so no one could get a link if they were not part of our team. And what I figured out is, since I'm not talking about the game, or I'm not revealing anything internal that I shouldn't reveal, then why wouldn't I not just go ahead and make the stream public? Because I have people who are watching me who are subscribed to my channel, and so here we are. Yeah, I'm just gonna address a couple of things in the chat. Well, a singular thing, basically. It's about particles. I will be kind of interested to do particles as well, because I want to study them more by myself as well. The thing about particles is that we're all waiting for the new thing, which is the, I believe it's called Niagara. I'm just gonna make a new tab here and go ahead and search Niagara. So we have this particle editor right now, which is called Cascade. It's really old school. It came to us from Unreal Engine 3. And now they are working on a new one, which is called Niagara. And actually, okay, I don't know if this is... Okay, this is not. This is April Fool's, I believe. Yes, so let's not push that. So Niagara is a node-based particle editor, and it's going to be much more, I would say, it's going to offer a much more creative way to make particle systems. I'm actually not even diving too much into the Cascade while waiting for the Niagara, and we have our designer here on the team, and he was willing to study the Cascade and do particle systems, and he found out that they're working on Niagara, and that probably it will be released before we do any major releases by our team. So everyone just said, okay, let's wait for the Niagara thing, and before that, not dive too much into Cascade, because Cascade is really old school. But it was that thing. So we're waiting for Niagara to land. I'm not even sure if it's in any of the major releases. By the way, Unreal has its own roadmap. So in case you didn't know, I'm going to quickly show you it. I think that's the one. Okay, so that's a new link, blah, 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 blah. Here we go. UE4 roadmap. I think that's the one, that's the official roadmap. Shipped with 4.16. Is it actually an official roadmap? Show menu. May, June, Charles, it looks like it is. Okay. Done for 4.17. Bug fixes, physics, cloth, launch, mobile separate lucency. No, Niagara. And actually, you know what? It doesn't. Have they really changed it so much? Let's see. Let's see if I can find it actually. And by the way, yeah, exactly. Niagara is like a visual scripting for the particle emitter, stuff that you do. At least that's how they present it. We haven't seen any like live demos yet, so I think it's far from being ready. Okay, that's the roadmap link. Okay, yes, they actually did move it. Okay, and I'm not actually happy with like the way how it's done here, because I don't even like. Okay, look, that's Niagara. No details. Node-based simulation system, real-time VFX. So yeah, it's here, and no one knows. There is no information here. We cannot even find out when the stuff will be going on there. Yeah, it is in future releases, but we don't know when. So the previous roadmap was much better. Anyway, let's get back to our Blueprints stuff. So quick recap. That's a new project that we made here. That's from the previous stream I was doing. So like it's not public, so I'm not providing the link right now. But a couple of things to note: we have our character here, and if we Control E, open him, it doesn't do much actually. It's just let's see, we have our third-person template here opened, third-person blueprints template, that is, and we have our movement input. Oops, let's see. Move forward, adds movement input just like usually it would, and then we just say, okay, this happens like every tick. Every tick of the engine input axis are ticking all the time for everything. And so we have to check, is the absolute value of this axis value greater than 0? And what that means is that, okay, right now this thing is ticking. If I just press Shift F1 to escape mouse interaction block, and I go back here, you can see that it's ticking all the time, every frame while we're possessing this character. This input axis event is ticking, but then the absolute value is 0. Now if we go ahead and start moving, it's not 0, it's either +1 or -1 or something in between. And the reason why it's like analogous, so it has like values in between 0, 1, and -1 is because we can use gamepads, and gamepads have analog sticks, and which is really useful, so we can like make the character move half the speed or something like that. That's great actually. It adds a lot of immersion to certain character interactions, to certain character mechanics, character movement mechanics. Okay, so we take ups of the axis value, and then we say, okay, play the movement montage. If we go ahead, this is the list of animations. This is a Demon Destroyer character that I actually purchased on the Unreal Marketplace. It comes with a skeletal mesh of the character and with a bunch of animations. So there is a way to actually make animations play from blueprints. And to do that, all you have to do is actually go ahead, right-click on animation and create Animontage or montage. I think it's montage. So then you just open it right here. And by the way, don't get confused. This is Unreal 4.13, so it has a little bit of old interface. Just don't mind that. But you can see that we have this our new montage here. I click Save. I go back to my code. I make sure that I am in the character or character deriving blueprint class, and the mesh for this character deriving class is the same skeletal mesh that this Animontage that we made is based on. So this is exactly the guy. If we open him, we can go back to animations, open the montage, it's here, and so now we can go back here, even graph, and we can select this montage right now. So what this code does, well, let me just make it so it's even more clear. By the way, you can double click on the linking, how do you call it, like connection strings or whatever it is, and it will create a new like connector, which lets you make more fancy lines, basically. I'm just gonna delete this guy, put it like this. Oh, okay, that's one of the issues with them. You have to make them carefully and not delete them. Let's see. Okay, so we play the montage. And then again, this is something from the old Unreal version. In the new Unreal version, this output will be delayed by the right time, depending on the time the montage takes. For example, right now, this particular montage takes, let's see, 0.567 seconds. So in the new Unreal version, when you output this execution node, it will be 0.567 seconds past. But in this old Unreal version, this is the atomic node, I think that's how it's called. So this one is atomic code, which basically means that whatever comes next will happen the same frame, the same tick. And we don't want this, because what we want is actually wait for the montage to play and then let it play again. And if we don't do this, if we don't use this basically this is a gate. It plays one, it goes through once, it closes, waits, it starts playing the montage, waits the amount of time the montage takes to play, which is this output, and then it opens so that it can start playing again in the next frame when this node comes. Okay, so if we don't do this, we just every frame we start playing montage, this is exactly what will happen. Play. And you can see that he's kind of like frozen. And he's not actually frozen, he just plays the montage every single frame, every single time that my input axis is not 0 or my input value is not 0. So we don't want this. We want to wait until the montage is played and then do it again. Compile, save. So now it plays, and when it finishes, it plays again. Let's go back to walk montage. So now you can see it plays the whole walk animation and then it starts again. That's what we need. But okay, actually, like, I gave this quick recap of what we did in the previous stream just so that you guys can understand this small amount of code that is here. Let's talk other code. This is just redundant. Okay, so when we press F button, we have this sphere, which is a collision sphere. You can just add components, sphere collision or capsule collision or box collision. And we set it to, well, this is the default value, overlap all dynamic. So all the objects will be overlapping it, basically. And you can actually check here. Everything is overlapping, all the channels of the collision. And so one of the usual things how people make interactions between objects and components is that they use these events. So for example, on component begin overlap. Whenever this guy overlaps something, we can do something, right? This is basically the fundamental principle of reactive programming. Oops, sorry, that's the hotkey on my mouse to switch desktops. So the idea is that we're not constantly doing anything. We're waiting. Well, we're doing something constantly, but for most of the stuff, we use handlers and we make the code work whenever something particular happens. And okay, so what do we do with this? Well, we're not actually using this on component begin overlap. We go ahead and we say, okay, when you press F button, we get the array of all the overlapping actors of our overlap sphere, which are deriving from this particular class. I will dive into this class in a minute. Then we say, okay, for each element of this array, let's cast to this class. And basically, if this get overlapping actors method gives us a non-empty array, every element should be successfully cast to this class because we mentioned this class in this query. But we cast it safely anyway. When you know for sure that the cast will be successful, you can always do this. Cast, let's say player controller, right click, convert to pure cast. Now pure cast basically says, okay, just cast and give me the resulting object of the cast class. You can still check the success, but it will be the same thing as this. The problem is whenever cast is unsuccessful, Blueprint will throw an error, and this error is not going to crash the game. Let's actually do this. I'll show you. So let's say controller possesses something, or okay, unpossess. Okay, so we do this. We go like that, and this is after we press F. Save, compile, play. Okay, so now I press F, nothing happens. When I click escape, still nothing happens. Actually, because the array was empty. But let's do something even more stupid. Let's get reference to self. This, cast ourselves to player controller, which we are clearly not, and unpossess. And we do this immediately after pressing the button. It says, okay, player controller does not inherit. So it says, like, on compile time, I can say that you're doing bullshit. But, you know, keep doing it, it's just a warning. Okay, play. Press F, nothing happens. And we got errors after we stop doing the thing. So in this way, basically, what happens is that you can still even ship the game with these errors, but of course they are there to show you clearly that okay, this doesn't work, and that they show why. Access none, trying to read property, blah 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 blah. That's the thing. All right, so just get rid of this part, and we go back to doing the same thing. So we get an array of overlapping actors, and for each of these actors, cast to this class and move box. So okay, what is the move box? Well, you can just go ahead and double click on this method, and it will send you directly into this blueprint for this class. Boom. Here we go. Okay, so what is activation thing? Well, it's a blueprint which is derived from actor, has a sphere for overlapping, overlaps all dynamic, and it has a child component which is a box, static mesh component set to box, blocks all dynamic, so it has collision with it, and all the code is just a singular function. This is just nothing. It's one function called movebox. And what movebox does is it uses this fancy move component 2. Now, move component 2 actually is really nice. It smoothly moves the component from one point to from the current position to the relative location and rotation. It can ease in and out, and you can even say exact time it should take to move. So in this case, we say okay, 1 second. All right, so compile save, and again. We'll close these guys. So it will call this method on all move boxes in the radius that it sees when it overlaps. And you can see here on this overlap sphere component, I clicked on hidden in game, so I disabled this checkbox. And because of this, when we start playing, you can see the red line, red sphere here. Of course, you can see that, well, on stream it's pretty clear, I think, that it's not super visible, and one of the reasons is post-processing, of course. Actually, that's the main reason. So if we go to post-processing settings, anti-aliasing methods, none. Now we can see it a little bit more clear. We don't have anti-aliasing now, but we're developing, right? That's one thing. Then there's another one, which is blur. Motion blur. I don't know how many people like it, but I don't, so just switch it to 0 for development time at least. And now when we move, we don't get any motion blur, so we can clearly see our red sphere. Okay, so you can see these white boxes here. All of them are actually activation things. And so we click play, we go near them, we click F, and they all go up, right? Nice. Okay, so we've got that going. What is next? And why am I even doing this whole thing? Well, the thing is, in Unreal and in game development in general, in a lot of parts of game development and in programming, like UI programming, other stuff, data visualization, we handle a lot of asynchronous things. So things which are happening for some time, and you may not know for sure when exactly will they finish. For example, activation thing is latent node. What does it mean? Well, latent means that it takes some time. You can see this white clock sign. It means that the output will only happen, or will only get powered, whatever you want to call it, when this node finished, and this node is not atomic, so it will take some time. For example, print string hello after it completed. Okay, so we go F, they moved, they finished, they say hello. He moved, he finished, he says hello. Nice, right? Okay. So the question arises. Well, first of all, what are other areas it will happen in? Well, the simplest example, of course, is not from game development. Simplest example is database access. You have already your database, and it takes time. In ideal world, it's instant. You say, okay, give me all users with this username, or give me all the users of this group, or whatever, and it just happens. Or even you're writing some kind of code that takes some files, downloads some files from the server, and does something with these files. Or you're even in the game where you're writing the netcode. That's how it's called, I think. Netcode for the game, and nothing is instant. Essentially, everything takes time. And so the question arises: okay, how do we handle this idea? How do you handle? I'm just reading the chat. Sorry. Nice. A lot of people are coming. More, well, not a lot, but more people than I expected. Anyway, sorry for the distraction of myself. How do you handle this idea that things take time and we are in this flow of the programming code? Well, I actually already referenced this in the previous stream, but I'm going to quickly show again the point that I'm making. So, Visual Studio Code. Let's save this file really quickly to the hard disk, whatever that is, and just make it like stuff.js. Actually, I'm just gonna call it like stuff.js, so that we get the JavaScript autocomplete and everything. And actually, syntax highlight is the important part. Okay, so let's say we have a function. First of all, this is the func2, func3. So let's say that we have executed this three things. So after we execute the first thing, it will go to the second thing. After the second thing executed, it will go to the third thing. After the third thing executed, we go here. So this is called synchronous programming. This is totally fine. Now, how do you make it happen in JavaScript? And I'm making a point of JavaScript, of course, because a lot of people use it, and I use it personally, and it's really easy and fast to just hop in and write some code, even right now on the stream, even though I'm not going to execute it. But in JavaScript, how do you go around the problem of, you want to wait for 1 second and then do something? Well, in JavaScript, it's easy. You use set timeout, and let's now set timeout is a function that takes 2 arguments. Now the first, well, actually it takes like infinite amount of arguments, but that's the point. The point is this: the first argument is the function, actually, and this function will do stuff. Or we can even say that you just call this function by name, right? And we can write it somewhere else, like. So we say, okay, do stuff after 1 second. Now, what will this thing do actually is it will say, okay, this is the definition of the function. And I don't know, guys, if you know like ES6 in modern JavaScript, but in modern JavaScript I would write it like this. But it's the same thing. It's a function which takes no arguments and does some stuff here. And then now it will say, okay, set timeout. So after 1 second, I will set some kind of timer for myself to do some stuff. Meanwhile, while this timer is already set on my event loop, I will continue, do func2, do func3, synchronously. But whenever 1000 milliseconds pass, we will go ahead and call this do stuff thing. And of course, it's a JavaScript, so you can make it like so. And it's the same thing, just it's called anonymous function, so we don't need this part. But the point being that we do not wait for 1 second to pass. We actually set a timer, and while this timer is, so to speak, ticking, we're doing some other stuff. Okay, great. Unreal. Well, guess what? whenever you are anywhere in your code and you say delay for 1 second, what essentially happens is the same thing. And it's really easy to illustrate. So delay is like set timeout in JavaScript. It sets a timer, or well, so to speak timer, for this amount of seconds, in this case 1 second. After the timer expires, it does the stuff that you put in to complete it. And meanwhile, it doesn't pause the execution. And that's really easy to demonstrate. Let's say that we are in this third-person character again. Let's say we use hotkey J. Nice. So what do we do? Well, let's make a sequence. Sorry. Yes. So what is a sequence? Sequence is just several events happening one after another. Blueprints don't allow you to do any parallel stuff. You cannot execute 2 things at the same time. So I cannot say, for example, run 2 sequences at the same time. It will say, okay, you have to decide which one. And sequence is used because we need to decide what comes after what. Blueprints runs on a single thread, roughly. That's roughly how it works. And we're not going to dive into details. But the point is that you cannot do 2 things parallel. You can do asynchronous stuff. But first, let's do this really quick example. So after I press J, it will say hello 1. Just then Control C, Control V. It will say hello 2, and it will say hello 3. And let's even change their colors. And by the way, I did this on previous stream, but in case someone missed, or well, the stream wasn't public anyway, so most of people who are watching right now probably missed it. So we did 3 things, and they have different colors. So green, red, or like pink, and then let's say like yellow, right? Nice. So save, compile. Now what will happen? Well, you probably guessed it. Green hello, pink hello, yellow hello. Play. J. Yellow, pink, green. Yellow, pink, green, yellow, pink, green, yellow, pink. Okay. It actually happens in the reverse order. I have no idea why. Okay, so that's not the point. The point is that it does all those things one after another. Actually, okay, no, it doesn't happen in the reverse order. It happens in the right order because it starts from the bottom. So this is like a queue of lines, right? So first the green line goes, then the pink, then the yellow. And it happens exactly as you would expect it to happen. So the order is preserved. Now, this is synchronous code. What happens if we say, okay, delay, which is, as you remember, maybe set timer. So let's say we delay for 1 second, then we print hello 1, hello 2, hello 3. Now, if you have not worked with asynchronous code execution before, you would guess that it waits 1 second, does hello 1, does then hello 2, does then hello 3. No, it doesn't. It does 2, 3, and then 1. 2, 3, and after a second 1. 2, 3, 1 after 1 second 1. Okay, so again, it sets timer for this thing. Meanwhile, while this timer is ticking, it does those 2 things synchronously. Okay, so we got this out of the way. There is other way to set timer in the blueprints, which is more, I'm sorry, which is more powerful, and this is called, surprisingly, set timer. There are 2 ways to set timers in blueprints, by event and by function name. So let's just go ahead here. I'm going to quickly dive into how timers work in blueprints. Now, timer needs time, so again, 1 second, needs event, and needs a flag looping. Now, looping is a great thing. If you have not been on the previous stream, you may not know that every actor has this tick interval, and it has this flag stats with tick enabled. Now, if we go event tick, oops. If we go event tick, and every tick we say, okay, print string, and we have default parameter for the tick interval, what will happen is that every single event loop, oops, let's just delete this for now because it's empty. Every single event loop or event tick of the engine, which is, for me, I think it will be like 60 times per second, it will call this print string. And if you start playing, you can see there are plenty of print strings. What you can do is you can change this event tick interval to something else, like 500 milliseconds or 0.5 seconds. And then it does this every half a second. But really common problem. What if you want actually to have several functions that are ticking at different intervals? For example, you want to check one thing every 5 seconds. You want to check other thing every 10 seconds. Well, there is set timer by event or set timer by function. Let's talk about the easier one. Set timer by event. Let's say every 5 seconds we want to do the thing. Event is not a full object type in Blueprints, or yeah, full type in Blueprints. So you have to like write this create event. Actually, no, I'm sorry, custom event, because create event is something else. So let's say print stuff. You can connect it here and say it loops, so it does this many times, or well, it does it every 5 seconds without stop. You can stop it actually this way. Promote to variable the handler, so store the handler for this event in the variable. Let's say it's handler. Okay, and then let's say when you click K, like some Vim shortcuts. When we click K, we take this thing and we say clear and invalidate timer by handle, like that. Okay, so every 5 seconds until we invalidate and clear it, it will print some stuff. Stuff that says hello, for example, right? Okay, so it doesn't print anything. I say J. Let's see if we got it. Yeah, so there is this 5-second mark. Let's make it even smaller. Let's make it. Let's get back to 1 second and J, and you can see that it prints every second. And if I press K, it invalidated the timer, so it doesn't do this anymore. Really handy. I think you can even do some other stuff with the timer. Yeah, you can pause the timer and then resume it. So many possibilities here. And of course you can make it like one-time timer. So this was a quick dive into timers, but we diverged a little bit from our main thing here. And our main thing here, of course, is asynchronous interaction in the game logic. So I will tell you the problem, then I'll show you the solutions, from the most primitive solutions to the more elegant solutions. And the more elegant do not necessarily mean, you know, the fastest one, okay? But the problem is really easy. We have our box here, as you can see, it moves, or the box gets moved inside this activation thing. This is one of the many things that, you know, one of the many asynchronous issues that you will face. There will be much more complex ones, especially with the animations. If you do animation heavy game, you know, you have to handle when the attack finishes, when the combo finishes, when the, you know, the weapon firing, because nothing is instant, everything has to be animated, particle emitters, expiring, everything, all of this is asynchronous. So this simple example hopefully will illustrate to you how do you solve this problem fundamentally in Blueprints. And of course the same concepts actually translate to C++, JavaScript, anything. Same logic, even more advanced stuff. It's not even in Blueprints, because Blueprints is limited to its domain, which is game development. Okay, so the box gets moved, and after it's moved, we want to do something else here. For example, we want to print box finished moving. All right, so how do we do it? Because this is an event. Event means that it can do asynchronous stuff, like this thing is latent, so it takes time, but it cannot do any outputs. You cannot put any outputs for the event because it takes time. It's not latent, or sorry, it is latent in Blueprint terms. So what do we do? Okay, I'll show you the I'll show you the most primitive solution, because for now we have this thing. We have this overtime set to 1. It's the variable which is set, so we know after 1 second it will be done. So okay, let's wrap this event around. How do you do it? Well, without doing too much refactoring, we have an event, we connect this overtime here to the input, boom. Overtime is automatically an input for this event. And we create a new function right here. Okay, so really quickly, Blueprint's functions. The advantage of them, they can have outputs. The disadvantage of them, they cannot be latent. So they cannot perform any action which is not instant. They have to be synchronous and atomic. So we call it sync, for example, or let's just call it like movebox sync for now. And sync means synchronously. And we're just gonna remove this async movebox. And now we can rename this thing to actual movebox. Nice. Compile save. Okay. So movebox will be a little bit smarter. Movebox will actually output float, which will be time to wait. And it will go ahead and call async movebox. And this movebox can have an input. Well, actually, no, let's not make any inputs. So now here we can just create our local variable, which will be, movement duration float, default to, I don't know, 2 seconds, right? Go here, async movebox over 2 seconds. It will take time of 2 seconds. Save, compile, go back here. Now this movebox now acts the same way as AnyMontage. It outputs to you the amount of time that you need to wait until this thing finishes. So now we can say, okay, delay. And after this delay finished, we can say box finished moving. Let's check if it works. We'll go here. Let's just overlap this one box. And like this, and press F. Stop moving, box finished moving. Nice, it works. So this is one solution, of course. This is like, there are really bad solutions or inefficient solutions when you use variables to check if the box has finished moving. And some people say, okay, well, we can use this as well. Set timer every tick. We can check if the variable changed, and change it after the box finished moving. Okay, aside from really like old school C style roots of the solution, the problem is even bigger. Imagine you have a lot of stuff that happens asynchronous. You have this big, giant mass of state change. Like character has rolling animations, jump animations, attack animations. You have to figure out, okay, which exact action is he finishing now? When will he finish? And how do we actually handle whenever he finished? If you do this with variables like booleans and wait functions and delays, first of all, the performance will be really bad. Second of all, you have big state, you have a lot of stuff happening. That's it. You cannot manage your code anymore. And blueprints are not good at this, both visually and in sense of performance. And if there are any web developers here, you guys probably know React and Redux, and how React has issues with the state change of the user interface in web applications built with the React framework, and how Redux and like a lot of other solutions are designed specifically to manage the state of the application. And the same thing is here. We need to have a good state handling. For this, we need efficient and easy to handle solutions and mechanisms to work with asynchronous execution. Okay, a lot of talk. How do we actually do this with a more elegant solution? Let's throw away this double function approach. Move box, we just destroy it. Now this thing will say, if we try compiling this, let's see, third person character. Now it switched to async move box. I don't know why, or did it actually? Yeah, it did move to async move box. Really smart actually. Usually just throws an error, whatever. Okay, so without delay, how do we do it? Well, more elegant solution, and which is oriented more towards, you know, scalability, so to speak. When you have a lot of stuff happening, and for example, you have a lot of people listening to the fact that this box moved. For example, there are 3 players, and each of them pressed the button, or several things need to happen right here in third-person character and in other blueprints after the box finished moving. So how do we handle that? Event dispatchers are the answer. And in case you're wondering, guys, there is a reason why I don't talk while I'm typing. My keyboard is mechanical cherry mix blue, and it's like really noisy. I think you hear that. So I don't want to like pollute the sound whenever I'm talking and typing the keyboard. So there is that. Okay, so I created a new event dispatcher. Now, what is event dispatcher? Event dispatcher essentially is this kind of storage of callbacks, so storage of functions that you can call, and whenever you call them, they all get executed at the right moment. And you can bind new functions on them. So basically, like you can look at this as some kind of like object which has an array of functions that you pass, to it. And whenever you say to this object that, hey, you should fire now, it will take each and single one of those functions and execute them. Okay, so like to make it even more clear, let's say we have this, we selected it, we have inputs, and usually the way how I do it is first argument is class or the object that it uses. Now, why am I doing this activation thing, object reference, is because sometimes you assign your event handlers on event dispatchers from different classes, and you don't know, like you need to know the exact instance of the object that you need. You will figure this out. You will face the same issue when you have like many objects and event handlers. I just don't have time to simulate this kind of architecture right now. So let's say activation thing. So box finished moving, and after completed, we call, like, notice I carried here, I say call, and it says okay. And let me just compile this, and it crashes because it has issues with the signature, and now it doesn't. So now we can say and by the way, you don't need to have this argument here, you can have no arguments at all. It's just something that I suggest you establish as a practice, that you have this one argument, and the first argument is the reference to yourself. And so one other good thing about this approach, again, anyone who is listening, who is bound on this event dispatcher, will instantly receive a notification, so to speak notification. And I'll show you how it works right now. So we have this activation thing, and we have to do two things. First of all, we of course want to start moving the box. But other thing is we want to attach or bind ourselves to the this event dispatcher, because we know that it gets fired whenever the box finishes moving. So usually the way how I do this is I make a sequence. Yeah, guys, in case you just hopped in, because I only now realized what was the message, what was the question in the chat. You will have an opportunity to watch the stream from the beginning, but in essence, I'm talking about asynchronous execution of things. There is no like specific content topic. I'm just explaining the way how you handle certain problems and blueprints, and I'm trying to provide as abstract of an example as possible. So okay, getting back to our thing. This is what we want to do after the box finished moving. Let's take our activation thing, and now we have our box finished moving. Okay, so and we have several things that we can do. We can assign new event, we can bind an event, we can call this thing, which you shouldn't do, of course, because you are not allowed. Well, you are allowed, but you shouldn't do this because this thing should call on itself. And you can unbind all events, or you can unbind specific event. Usually, you want to go for assign, of course. And I will explain the difference between assign and bind in a second. So you go to the assign, and it creates two nodes for you, which is unusual, and it offers you to name the red event you can see. So let's say on box finished moving. This is the event that will be called by the event dispatcher. So whenever this call is happening, this will fire off immediately. So we bind on it, and we can even say, okay, let's update strings. And this is like one of the ways how you can utilize the fact that you have the reference to the actual object, which is the owner of this event dispatcher. And you can even go ahead and connect those two things, like string and object, and it will get display name of the object. Sometimes it's really handy when you're debugging stuff. Okay, so whenever the box finished moving, so like notice we are doing it in reverse. First we say, okay, whenever the action will finish, this is what you do. But now we need to call the action itself, which is really easy for now. We don't have to do anything fancy. We don't have to call wrapper functions like we did before. Just call async move box. And this parameter, well, it doesn't actually matter right now. Because you can still say, okay, it takes particular time because we put this time as an input. Well, no, it just takes random float in range, okay, from 0.5 to 4 seconds. That's actually the way how you do a lot of like random stuff, random explosions and everything. So it will take random time. Now we don't know at all how much time exactly it will take. Okay, so now we do really need this event dispatcher. And of course, one more thing you can do, because remember, this event fired, but it will fire again if this thing happens. So I'll show you this right now. Whoops, it says that this doesn't exist anymore, and that's true. Because now this thing is like that. No. Yep, because we need to compile this thing first, and now this thing is fine. Yeah, by the way, if you face this kind of issue, go make sure that the blueprint that defines the function is already compiled, sorry, and only then try to compile this blueprint. Like, okay, so let's go to this box. Say F. It says activation things, box finished moving, and of course other things work as well. And you can see that they even move at different speed. And you can see that they print the name of the object. And let's even do it like same time. Now you can see the power of randomization and the power of event handling. So we have this, boom, boxes move in different speed, and you don't even know as a programmer whenever which box finishes first, which is exactly what you need. Not the uncertainty, but the variety, so to speak, in the gameplay. Okay, so this was the second solution. Now, before we finish, let's go towards the third and the most exciting. I have to warn you. First thing is that this solution is not fully implemented in Unreal as of now, and it's only available through the third-party plugin called Low Entry Library. I think it's called Low Entry Blueprint Library. I'm just going to show you in a second. So that's the Unreal Marketplace. And by the way, don't worry, I'm not affiliated with this plugin, it's free. So Low Entry. Okay, that's the guy, Low Entry. I don't know if it's a guy or a company, but yeah, LE Extended Standard Library. Great thing, by the way. Heavily rely upon it in our projects. There are like, what, 200 blueprint nodes, something like this. I highly recommend you use it. But one of the features it offers is actually something that's called, in a weird way, it's called Latent Action. You probably have never heard of it because that's not how this concept is called usually in other languages. But latent actions let you create what's usually called in programming languages as promise or future. Now, what is a promise or future? Let's get back to the VS Code and write some JavaScript. Okay, so I'm just going to pretend I have a function that returns a promise. Let's say there's a function called, and I'm just going to show you the signature, I'm not going to show the function itself. So it's called access. It's a function that takes like, let's say it takes like a name, and then it has its body, its stuff, and again it's a function. Oops. And because it's a JavaScript, you can even be more fancy and do it like this. But what this is actually is a function that has one argument, which is called name, and this is the body. And this function returns what is called a promise. And the promise has a bunch of stuff. It has its own functions and arguments. I think in JavaScript it's resolve reject, stuff like that. Resolve. Okay. And now we want to access the DB. So you will ask me, okay, what is this promise? How does it work? And now I have to show you really quickly now. So what's cool about the promise? Promise essentially is an object which again can store two, basically you can look at them as two arrays of callbacks, of functions. Callbacks on successful execution and callbacks on unsuccessful executions. In this case, resolve and reject are the method that you call inside the promise, but that's JavaScript specific. The main point that you have to understand is essentially that when you have a promise, it's something that the function which executes not immediately, which executes, in a certain time period, this promise means that it contains possibly, or well, probably a result which is not yet there, but there is a promise that either this result will be there later and then all your onSuccess functions will get called, or something will fail and all your functions bound on failure will get called. And it's the concept which is cool because you can pass around this promise. So you can pass around this object which will at one point give you the result of what you need. And it might sound really, really so to speak, confusing, I think, but let's just quickly do it. So access promise equals access DB, and let's say we do this. Okay, so now access promise is the result of this function. This function does stuff in a certain period of time, but it will synchronously return a promise. So immediately on this line of code, access promise will be a promise already, so the function will return even though the result is not yet there. And now you can do two things. First of all, you can say, okay, access promise dot then. Now then is the way how you add to this promise new success handler. So you can say function success result, for example. Oops, because the function I did this, and then console. So what did I do right now? Well, I said, okay, bind my function which accepts as a argument access result, bind my function on the successful execution of this promise or successful completion of this promise. So whenever in this promise I call resolve, this gets called. And I can also do this, says promise dot fail, or actually it's called catch right now. Okay, what does it mean? Well, it says, okay, on success of this promise, bind this function on it, or call this function. If the promise fails, call this function. There are many things more about the promise, but the main point is that functions that take time to do stuff can actually return immediately. While they are doing stuff asynchronously, they will return a promise, and this promise will get called whenever the synchronous stuff is finished. So the promise will have its then results working or executed. Unreal in LE extension library has it. Let's really quickly do it. So third-person character. And by the way, in next stream I will continue exploring this. I will show you how to make it more fancy visually. But for now, let's do it really quickly here. So async move box. Well, let's go here. There are many ways to do it. Let's make a wrapper. Well, actually, that's the one way, but there is the other way as well. Yeah, I think that will be more nice to have a wrapper visually. So move box. Now move box does the same thing. It goes here. It says, okay, async move box. So call async move box, but it will do something else as well. First of all, let's create a new latent action. And remember, the way how Unreal works, or the way how LE extension libraries work they call it latent actions, but you can make them work as promises because they're basically the same thing. There are some bugs with them, so be careful. Okay, let's just make a new latent action. So we create a new promise, and let's make it so that this async move box actually accepts a promise, or, well, latent action. And make it none. Okay, so it needs this reference. It's called, I just called them promises because that I come from JavaScript and Scala background, or TypeScript, whatever you call it, CoffeeScript, many things. So instead of using event dispatchers, let's just delete our event dispatcher. And after this thing happens, we call done on this promise. Boom, boom. So movebox will give this created promise here, and actually it will output it as well. So promise output, and so we created latent action. We gave it to our async movebox method, called it with this method as an argument, and returned it. So now in our, let's quickly save, in our third-person character, we can do the exact same thing. Oops. Instead of binding the event, we can actually call movebox. Oops, I think I forgot to do the compilation part. So movebox. It's a method, it returns a promise. And so this promise if it happens so that on the same frame the promise is already done, so for example, you know, for some reason this code is instant, like this is 0 for some reason, just in this case it shouldn't be, but in case it is, we say, okay, if it's already done, oops, sorry, if it's already resolved, then we have to do our print part. Say box if it's already done here. But if it's not done, let's use this wait till done. Wait till done is basically then. So it says, okay, bind the function that comes from here, but in this time we don't bind it on timer. We actually just give it our promise. Whenever the promise resolves, it will call it. Boom. So compile, save, and play. And F. Done. Done. Whoa. Yeah, it makes it for each loop. Yeah, so that's one of the bugs of promises. Whenever it did it first time, I think then it bugs out. Or it's not that doesn't bug out, but it has the caching thing. So if we make it for a singular one, let's just check our theory. It will work for a singular one, yes. But if we do it like second time, yeah, actually it does still work. And the third time it works, yeah. So it was an issue with like doing it in a single frame for each loop. If there's one, it works. If there are several ones, the promise gets cached. That's the way how I understand why it doesn't work if we have several objects. And I faced this issue before. That was like that's the bug, the reason, or not the bug, well, the reason, the behavior because of which I'm not using promises everywhere, only in some instances. Okay, so. We're wrapping up our stream right now, actually. We talked about event dispatchers, promises, timers, the way how event tick works, the way how blueprints handle asynchronous execution, solutions to it, and of course, LE extension libraries, latent actions. So you're encouraged to dig deeper into latent actions and other stuff. Next stream, hopefully it will be next week, I cannot promise right now, promise. Hopefully next week we will talk how to make this a little bit more fancy, the whole promise thing, and you know what are the solutions to, you know, what are the things to avoid, because this is one of the examples how you should avoid promises or using latent actions, should I say. Thank you for watching. Hopefully you got something new from it. The stream will be available as an archive publicly. Hopefully, you know, I think it will take like a couple of hours and then it will be available. So thank you for watching and see you next week, guys. Hopefully next week, or see you next stream. Bye bye.